Today we're going to talk about calculus, and in calculus there are about 5 things you talk about, and the first case that we talk about is the first principle. This is when you use a formula to differentiate a function, in this case to get f of x prime. And f of x prime in this case is equal to limit as h goes to 0 f of x plus h minus f of x over h. Of course, this formula is given to you in the exam, so you don't really need to remember it, but through practice you tend to get used to using it and you remember it naturally. Now, suppose we have we try to apply the first principle on a linear function. So I'm going to write down a linear function here. F of x is equal to 2x minus 3. Now, this is a linear function. If you remember your analytical geometry, you will remember that the y is equal to mx plus c. So in this case, this is we call this a linear function, and we want to differentiate it using first principle. So first of all, we take our f of x and we find f of x plus h, which is going to give us 2x plus h minus 3. Now, once we've got our f of x plus h, we can now proceed to substituting into the first principle formula. So when we are substituting into the first principle formula, we know that f of x prime is equal to limit as h goes to 0, and in this case we're now going to substitute. Instead of putting f of x plus h, we will put what the function is, which is 2x plus h minus 3 close bracket, and then also we substitute for f of x, which is 2x minus 3, like that, divided by h. Now this will set the platform for us to now expand the brackets. So now f of x prime is equal to limit as h goes to 0. I am going to expand the bracket inside the big brackets, so this is going to be 2x plus 2h minus 3 close bracket minus bracket 2x minus 3. And the next stage will then obviously be to remove the brackets. So we're going to remove the brackets. F of x prime is equal to limit as h goes to 0 there, and here we're going to write 2x plus 2h minus 3 minus 2x plus 3, and that's because we are removing brackets and there is a negative sign right there before that bracket. So instead of getting a negative 3, we have a plus 3 at the end there. So now we're going to see that if we look carefully, if we are looking carefully here, this one will subtract this one, and obviously this one and this one will negate each other, which means that they will cancel out because of subtraction. Negative 3 plus 3 is 0. Then we are going to have our function f of x prime is equal to limit as h goes to 0, and now we have got 2h over h. Now, this is the interesting stage, because the whole idea of first principle is to make sure that we remove the denominator, which is h. Remember, we want to take our h and make it approach 0. In fact, it's going to be 0. Once h becomes 0, that whole function becomes undefined. So it's unacceptable to have the h there. So if you look now, we can easily cancel out the h on top with the h at the bottom. We no longer have an h which is a denominator. So now we can say f of x prime is equal to limit as h goes to 0, 2. Now if I say h is equal to 0 at this particular stage, it won't affect my function. So my f of x prime will remain f of x prime is equal to 2. Now here, at the previous stage, I took the limits. I supposedly made h equal to 0. But there was no h, so therefore it did not affect my function. And that, ladies and gentlemen, is how you would find f of x prime.